So welcome everybody to this webinar about smart city technologies, LiDAR on the Tay Road Bridge. I hope you have a really good time. Unfortunately, Julie couldn't make it today because she's off ill, so I'm just taking her place. I'm sure I'm not as good as she would have been, but it's I'll try to do my best. First of all, I'd like to introduce today's panelists. They are, if I mention your name, please just give a little wave. So we've got Doug Young. He's the Business Development Officer at Dundee City Council and T5G. We've got Steve Gillen, the Director at Digiflec. We've got Andre Tapandenas, who's a geospatial analyst at Digiflec. We have Jack Walland, who's the Technical Delivery Manager at the Scotland 5G Centre. And finally, we've got Alan Hutchison, Bridge Manager at the Tay Road Bridge. So as you can tell, this meeting is recorded. A recording will be shared after this call. If you do have any questions during the call, please put them in the Q&A because we've reserved a good chunk of time towards the end to go over any questions you may have for our panelists. So without further ado, I will go to Doug, who's going to briefly introduce us to the Tay5G program. Doug.
Thanks, Maddie. So, yeah, the Tay5G project, that's come out of the Tay Cities deal with, it's got an aim of encouraging and supporting engagement with 5G across various sectors, reflecting the sort of various sort of regional strengths and also our priorities as a region. So what that consists of, well, it's £2 million for innovative use cases tied to those regional strengths, and to kind of list off some of them, but not all of them: esports, drones, fashion, creative arts, virtual production, broadcasting, and of course the reason we're here today, IoT. So you're talking quite a broad range of things. It's not just kind of city management and all the rest of it, but that's obviously going to be a key part of it as we find today. But it's really looking at a broad range of sectors there and sort of understanding what it is we can do with 5G, where we can design better services, where we can really innovate, and that's what it's looking to do. And that's also all underpinned by 3 world-class 5G networks. We've got private 5G networks for R&D that are set up in Dundee. They're not directly connected to the Tay 5G project, but they're a sort of key part of the offer. And we really see them not just as a Dundee asset, but as a regional and national asset as well. So one of those is an outdoor 5G testbed at the Dundee waterfront, but also there's 2 within Aberdeen University, including at the Cyber Quarter, which was another Tay Cities deal project. So that's just a very quick run through in terms of what the Tay 5G project's all about. I'm sure something we can send around later as a link to kind of with some more info of some of those other use cases. But today, obviously, we're here for the LiDAR on the Tay Road Bridge webinar, sort of showcasing that. So yeah, passing it back to yourself, Maddie, just to introduce the next person. Yeah.
You're on mute.
You're on mute.
Apologies. So next up is Steve, who will talk through the project background and aims, but also the capability of LiDAR. Steve?
Sure. I'll bring up a presentation for everybody's benefit. So first and foremost, thank you everybody that's taken the time today to register and attend. I hope you find it insightful. I want to give you a bit of a background. So my name's Stephen Gillen. I'm the director of Digiflec. We have quite a diverse and knowledgeable team supporting Digiflec. It's growing every year. We're a self-funded company. We'll be 4 next month. We're based in Dunfermline and Fife. And we specialise in 3D LiDAR technology. It's a sensor that we've selected for our systems development, and we also supply it across the UK. If you're not familiar with LiDAR technology, LiDAR technology is a kind of relatively new sensor that's development is accelerating mainly due to the automotive sector. It's a sensor that helps give vehicles eyes for autonomous functions, driving functions, and robotics as well. LiDAR stands for light detection and ranging. It's a sensor that emits an eye-safe light pulse, which will travel, reflect off an object, and return back to the sensor's receiver. It will then do a calculation to understand the distance that the light pulse travelled, giving us a distance measurement within the low centimetres accuracy range. And we also understand the reflectivity of an object. And what I mean by that is, if it's a dark object, it will absorb some of the light source and return a lower reflectivity rating. Or if it reflects off something like a number plate or a high-vis vest, it will give us a really strong reflectivity rating. On the Tay Road Bridge, this process is repeated 900,000 times per frame, and the sensor collects 20 frames per second. So why we select LiDAR for our systems is it has a lot of benefits over legacy technologies such as camera and radar. So we work truly in 3D, where a camera system might work in a 2D plane, make lots of calculations and assumptions over depth and speed and size. Whereas radar will give you 3D information, but the resolution will not be as strong as 3D LiDAR. So your classification ability might be less, or if you have a busy scene with big buses and small objects in front of it, it can be classed as one object. It might struggle with slow moving objects or lateral moving objects from the sensor. If it's moving to and from the sensor, it's really good, but lateral, it could maybe struggle for detection there. LiDAR obviously generates its own light source, so it can work in all lighting conditions. And because it's working with such a high resolution at the speed of light, it can penetrate through harsh weather. We collect really, really accurate speed information. These sensors can be used as a speed meter if approved by the Home Office. And everything we collect is GDPR by its nature. There's no personal identifiable information collected. So we've got systems installed in high schools and university for that very reason. The reflectivity information I spoke about, you can see there's different colours in this scene. So we've got the dark blue on the road because it's given us a low reflectivity rating, and lighter colours and even some yellows and reds for number plates on vehicles. That centimetre accuracy is really good for understanding the dimensions of a vehicle. So if you want to know if that bus, for example, would get under a bridge or through a tunnel, we can provide that sort of information. So yeah, we've selected that sensor because a lot of these benefits, and what our software does, it will take that raw data in and it will identify the moving objects and classify them, giving us information about their dimensions, their direction of travel and their speed. We will then further refine this data to take care of edge cases where we might have some false positives, just to give us the best data possible for data analysis and any application developments for things like smart cities and ITS. So why do we want to combine SIM with 5G? So these sensors produce quite a lot of data, and using previous generations of cellular connectivity, it wouldn't have the bandwidth to transmit that data over the air. So typically we would have to connect the sensor with an Ethernet cable directly to an edge computer, which would have our software. If you were to install this equipment on motorways or cities where you don't have the infrastructure in place for a cabled communication network, we would typically have to have an edge computer with every sensor. This makes the installation a little bit more complex, but also the bill of materials increases as well. And 5G technology has very low latency and very stable network performance. So we also wanted to understand if that could open up new applications, such as safety critical, timing critical applications like controlling traffic light signaling. So on the right is kind of a demonstration of where we move to with 5G, having a sensor connected to a 5G router in that white housing and having their software on edge compute remotely placed and able to process multiple sensors at once rather than previously one sensor. But I'm not the expert in 5G, so I'm going to pass you back to Maddie, who will introduce Doug, and he can talk about it in a bit more detail.
Yes, indeed. Thank you, Steve. So next up is Doug, who will, Jack will provide the use cases. Apologies, Jack. Who will show us a little bit about the setup in Dundee specifically.
That was really fun. I like seeing Doug squirm. So, I mean, I'll put a slide up first. It's just one infographic from me, not all the complex slides that Stephen has. This is just an oversight of what is potentially taking place in Dundee. It shows the existing connection and it shows what we're doing as we move forward. So my kind of role here is to cover an insight into what's taking place with regards to utilising networks available and where this allows testing to go next. So the system setup sees the LiDAR sensor mounted with a singular view of the activity on the bridge. Data is processed locally on a compute before being uploaded using a 5G router, which is a Teltonica Rotex 50, over a publicly available 5G broadcast using, I think it's the EE network. The data then goes up to AWS, where it's used to provide a live environment, which has quite specific benefits, crash detection, ring fencing breaches, unusual behavior alerts, and more that Stephen and his team can discuss. The performance of the broadcast, being a public broadcast, sub 50 millisecond latency and uploads of around 40 megabits or better allows us all to be possible. But the next step is in scaling this solution to multiple sensors. And therein lies the challenges relating to, as Stephen alluded to, cost, which is very difficult with multiple compute for each LiDAR. Obviously, you can't have 20, 30, 40 sensors if you're going to need to provide a compute for each of these individually. Security, public major network broadcast networks can be connected to by anyone with the right SIM card subscription, and therefore aren't the most secure. Equally, that data is controlled and going through a network that we don't actually have visibility of. And resilience, there's multiple points of failure, including contention ratios on the network in busy periods when lots of people move to an area and connect to a certain broadcast. And equally, control. We talked about security and resilience, but control is really important. Working with a network that operates in a fixed manner, not being able to prioritize traffic, these are challenges. So a private network, private broadcast we have in Dundee on the waterfront is extremely advanced, operating on a shared access medium power spectrum license. It covers a substantial area outdoors. It's capable of resolving most of the challenges I just mentioned. I mean, cost, it reduces compute. You've got a single MEC, which is a multi-access edge compute. It's just a computing resource which is connected to that network. Each LiDAR can then connect to that single compute and use the same network at no additional rate. Security, I mean, private networks are by design more secure, bespoke provision SIM cards and visibility of connected devices provide that. For resilience, separate data connections, support services, and even power can be arranged. And then we look at control, we can work with the supplier. So in this instance, it's Nokia, and we can work with them to affect the way the core of the network routes traffic. And we can change that as we see fit. I mean, there's obviously parameters within that we can't control, but we have much more agility. This will all be understood as we move through the next phase of testing in Dundee, where we have multiple sensors and edge compute connected to the Dundee City Council private 5G network from Nokia. That's happening in an intersection in the centre of town. Once again, the team from Digiflec can talk to that particular use case. Thanks. I'll hand back to yourself, Maddie.
Thank you for that. That was really, really good. So I think we're all quite keen on seeing actual footage, and for that, we switch to Andre.
Hello, I'm sharing my screen now. Yeah, so hello everyone. Just before I start, as someone who works with geospatial data, I'd like to give some context into the location of this data I'm going to show next. So we're talking about the Tay Road Bridge, which connects Newport Tay to Dundee. It was opened in 1966. It's a more than 2,000 meters long bridge, and we have our scanner on the south side of the bridge. The scanner is facing north, and basically this scanner that we have here installed, this LiDAR scanner, it picks up objects up to 500 meters. So it's quite a long range LiDAR scanner, and you'll be able to see here on this video that's probably just some points of the quite a distance. So those are just cars coming towards the scanner, and then you can see we have zones here. These green zones are detection zones, and once the vehicles enter those detection zones, the system starts classifying them, and we have several classifications. You see that the red ones here are cars. We have cars going towards the scanner, going north. These we also have the trucks. The white ones are vehicles that are not being classified yet. And basically, the closer the objects are from the scanner, actually the classification, just by the nature of the LiDAR scanner, there are more points or more reflections, light reflections from the objects. So the classification is improved. So we do have that classification. We have the vehicle speed and size as well. You can see that in here's kilometers per hour. We have those detection zones. We have exclusion zones. So if we want to ignore some part of this scene, we can do that. So if it's not of interest. So in this case, particularly, you can see that we are classifying the cars, but there is a central walkway on the bridge, and we at this point we are not trying to identify any objects that were on that section. We then have other algorithms processing the data and improving the classification. So we have some of the vehicles you see that we're classifying as trucks, but they can be lorries, they can be vans. So we can do then further improve that classification as well. So then we do have some outputs from the bridge. In this graph, we have the counts by type of vehicle and direction of travel, and we have cars, trucks, two-wheelers, which in this case will be motorbikes, and some unclassified vehicles, and we have some expected behaviors here. We had some low count vehicles in Christmas and New Year, and also you can see that on Sundays there's quite a drop of on the number of vehicles on the bridge. Another interesting thing, and that's why we can chose this period of time between the 16th of December and 11th of February, that I did have an operational issue, and you see that the counts dropped. The interesting about this is not actually the operational issue, but how quick we were in identifying it and fixing it. So within a few hours, we identified the issue, we fixed the issue, and we didn't even lose 1 day worth of data. With other technologies, this probably wouldn't happen. So I think I will probably mention this later, but it was quite important for us to kind of know that there was something that wasn't working as expected, and we could fix it. So you can see we still have more than 7,400, actually 14,000 vehicles detected on that day. Another very interesting point here was on the end of January, and this pink line are trucks traveling south, and you can see on the Wednesday that's quite a drop. And this was one of the storms that we had in Scotland in the end of January, Storm Ingham, and basically the bridge was close to double buses for most of the day, and that's kind of made a difference in the number of counts. So there are some details that we can pick up with the data. Also, very interesting is that the number of vehicles that we cannot classify is around 1%. So we have a 99% rate of classification of vehicles, which is quite impressive as well. And again, this is the total number of vehicles on the bridge. So the bridge is quite busy. Most weekdays there are more than 20,000 vehicles driving on the bridge. Sometimes close to 27,000 vehicles. So that's quite impressive. We also have some work in progress from our talks with the bridge team. So we're working on some algorithms to detect stopped vehicles. So vehicles that break down on the bridge. Try to identify those. We also have some algorithms working to detect vulnerable people. So if someone is walking on the bridge in the early hours of the morning, they stay in one place, we can also detect those people, or if someone is walking on the walkway suddenly jumps on the road, then we can also identify people that way and can communicate that to the bridge team. Again, going back to that storm on the end of January, when the bridge was for most of the day closed for double-decker vehicles or buses. We went back to that data to those recordings, and we actually saw that there were a lot of vehicles, buses that were driving or trucks that were driving there that weren't following these restrictions. So vehicle size restrictions, we can look into that and check if the restrictions were followed. That day actually there's 27 vehicles driving south or shouldn't be there, or 17 driving north as well. So that was picked up. And the last thing is the active travel. So on that walkway, at the moment, we saw that we were not counting the pedestrians or the bicycles that were on that walkway, but we can do that, and we can then provide even more information to the bridge team on how the actual bridge is used and the number of people or vehicles, trucks that use the bridge. Back to you, Maddie.
Thank you very much, Andre. That was really good. So we're now speaking with Alan Hutchison, and who's the actual bridge manager at the Tay Road Bridge. Alan.
Yeah, thanks, Maddie. Yeah, I'm Alan. I'm the bridge manager, so I'm responsible for the inspection, structural integrity, and the daily operation of the Tay Road Bridge. I just wanted to highlight the importance of data to us in understanding our asset, because being an asset manager, getting data is incredibly important for us to understand how the bridge is used and the loads that it's subjected to. It's also important to understand the vehicle crossings every day and who actually uses the bridge, and that allows us to understand how strategic we are with respect to the overall trunk road network, and obviously the importance to the economy of the east coast of Scotland, and that allows us to assist with negotiations with the Scottish Government for capital funds, revenue funds to keep the bridge going. Although we already do this because we've got traffic loops in the ramps on the north side of the bridge as you come into Dundee, and as you come onto the bridge on the southbound, the data that gets collected from these loops has to be done remotely. So you've got to actually go on site, plug your computer in and actually collect the data on site. And sometimes we get a bit of data loss that needs some manipulation from the manufacturer, but this of the loop, but this can often take sort of 2 or 3 months worth of data to be manipulated, which is timely and costly. And the benefit I see of a system like LiDAR would be knowing that you've got a fault straight away and be able to rectify that. And I think that would lead to sort of more accuracy. in understanding the vehicles using the bridge, the number of vehicles using the bridge. Also, when you're embedding equipment into the road surface, you're effectively creating a weak point and increasing your maintenance of the road surface. So the benefits of not having embedded equipment in the road surface for ongoing maintenance it would be key. I do like the idea of the real-time data gathering as well, and that allows us to understand busy trends, if you like. When is the bridge getting used more? And I think that would be useful. That's useful information that we can speak with our partners at Fife Council and Dundee City Council to help manage traffic around the rest of the city. So I can see that being a certain benefit, and it'll help with sort of public noticing and warnings of queues, etc. Also, the benefit of this system would be it allows the identification of different types of vehicles. You'll understand that at the moment we do not have accurate data of our HGV counts, and that's important to allow us to determine the wear and tear on the bridge. Obviously, 44-ton lorries put more wear and tear on the bridge than standard cars. So that'll allow us to understand the wear and tear, will help us with budgeting with the Scottish Government and comparisons to other bridges as well. So allows us to get our capital plans in place so we can plan ahead for repairs and maintenance. Some various elements of the bridge you might think will last 15-20 years, and actually the usage is a lot higher than you might have anticipated. So you might decide to bring that replacement forward, or indeed push replacement back. So I think the more data and the more control you get on understanding your asset and how your asset is used can only be a good thing with respect to both structural repair planning and financial planning. I was also very interested to learn of further the development opportunities. We have 32 cameras at the moment on the bridge and control room staff. So any assistance that can be given to them in spotting a broken down vehicle, or indeed somebody who's on the carriageway that's maybe walked up the Dundee ramp, for example, trying to get to the walkway, then that can only be a benefit to the wider society. So I think I probably exhausted that. My slide wasn't quite as exciting as the others, but I do apologise for that. So I'll hand you back to Maddie.
Thanks very much, Alan. It's so good to hear from, like, the real life side of this technology and see how it really impacts your team. So I thought that was brilliant. It's back to Andre and Stephen now, because they are going to share some of their lessons learned and also show some more video images. Steve, you're on mute.
Got me out. Let me share my screen again. So before I start playing, before I start playing this scene, I just want to thank Alan and the Tay Bridge team for working with challenge owners, having that two-way communication, identifying opportunities for further capabilities in the system, and we look forward to continue working with you with systems integrations and looking to see how compelling this technology could be, and if it could be potentially scaled across the whole length of the bridge in the future. We've learnt a lot from that deployment, and it's definitely given us a long list of development tasks, and we look forward to undertaking those. On the bridge, we had a directional sensor, long range, as Andre said, it was 500 meters, very high resolution, great for highways, motorways, where people are just going laterally, same direction, or in a security application, boundary monitoring, very good. We've also got a system in the city centre, so I haven't got a map like Andre had, because I'm not a geospatial analyst and haven't thought of that, sorry. Where, if you're familiar with Dundee, where this is there's a hotel called the Maison and the railway station. The railway station's kind of at the bottom of the screen. Maison is kind of the north-east of the screen. It's quite a busy junction if you're familiar with it. So in a city environment where people are moving in all sorts of directions, it's not lateral like on the highway. Different sensors are used. We use 360 degrees rotational sensors. So we have two sensors in this scene, one at the car park and one across. And they're kind of monitoring this area. And what's good about having two sensors as opposed to one is if you just have one sensor, you'll get shadowing or occlusions because the light pulse will reflect off the object and not be able to see through it. If you just have one sensor and say that was a bus and there was a car behind it, we'd temporarily lose tracking of that object until it came back into sight. So having two sensors and having this measurement information coming from both angles really improves the tracking and performance of the system overall. Working in 3D, what's really great is we can pass objects from one sensor to another sensor to another sensor, and we can continue to track the same object. So the scale of this could be, you know, across a whole motorway or a whole city, depending on what the application and the requirement is, across a whole supermarket, across a whole airport, whatever your application might be. So this is the scene in the city. It's quite a busy scene. And visually to the eye, you can almost make out what things are. But really it is just measurement information at this point. Our software will then take this information and start to classify what those objects are, giving us the dimensions, their speed, direction of travel. On the top left, we've got a car park, so we're monitoring parked stationary vehicles. There's a bus that's parked as well. It's the bus that takes you to the airport from Dundee. We've got pedestrians in an island, and yeah, just traffic flow in all sorts of directions. What's really great about working in 3D as well is the ability to create very accurate rules to space. So as Alan spoke about, loops in the ground, you know, legacy technology, which maybe weakens the road surface, you know, causes disruption to travel when they need to be repaired or replaced and can be quite costly. So we're able to kind of replicate that with some virtual loops. So anywhere you want, we can just create a virtual loop. These rule-based areas can be used for all sorts of applications. So here's just an example of the car park where we are saying, okay, we understand the car parking spaces is 40 and this is its capacity. If you want to create some rules against individual car parking spots, such as, you know, imagine it's a loading bay or time-based parking, then you can understand if vehicles have been there over their duration that's allowed, and you can send these notifications to whoever needs to take that. But these sort of rule-based monitoring areas, so is that played? Yeah, can have all sorts of rules in terms of minimum, maximum quantity, size of vehicle, the speed or the dwell. In this example, this is us demonstrating the ability for the system to maybe aid or complement traffic lights to make them a little bit more intelligent. So typically with traffic lights, you'll have weights in the ground next to the traffic light. Most cases, there's either one or two car spaces back from the traffic light. So if you have a junction and there's two cars at each junction and it's equal demand to say, hey, turn me green. But if you can imagine having the visibility to understand that on the left-hand side, there's like 40 cars queued up and only 2 on the right, you can just make that traffic light timing a little bit more intelligent and on demand. So if you've got like a concert or a football game and everybody's leaving the city or rush hour, you can start to make things more intelligent, or even you can create some rules in terms of the type of vehicle in there. So if you're wanting to prioritise public transport, you want buses to go through, or you want to get HGVs out your city, you can start to add some intelligence into it like that. Equally, if you are wanting to promote active travel or have a pedestrian-focused city movement, then you can replicate this for your pedestrian crossings, and you can even have them contactless. In this example, we're prioritising. We could be prioritising pedestrian movement in a city. This is obviously for traffic, but you can imagine this sort of rule-based could be applied to retail space in terms of resources. If you have X amount of people in a space waiting, then we need more resources in hotels or check-in areas in the airport. You can see some crossover in that. So in this scene with the two sensors, we're also understanding the relationship between objects. So at the pedestrian crossing right now, you'll see 3 people that start jaywalking across when it's a red man. And then we can understand, because we get the trajectory and velocity information of objects, we can start to understand the relationship of them. So we can understand where near miss detections happen. So rather than waiting for an accident, you can actually start to understand where your safety issues might be. And as you have a system permanently installed over different months, seasons, you can start to understand, we see a lot of near misses in the winter between this time of day, and it might be related to low sunlight. And a simple solution might be install more trees to prevent that sunlight glare and remove that and make it a safer environment for everyone. But having these sensors installed, we're not only able to do multiple tasks, such as the loops in the ground, the mobility on demand for how many people are queuing up for the bus or the car parking spaces, but we're also collecting data that can be really useful for urban planning and engineering departments. So if you're wanting to install maybe even a temporary system to understand how an area is used in really granular detail, to then maybe work with some travel consultants or active travel consultants to understand how the area is used and make sure that your optioneering costs are reduced. And then once you do these engineering changes, you go back and resurvey and understand, was it a good decision or a bad decision? What can we learn from this, or justify expenditure as well? So we feel like it's a really compelling offering for lots of different use cases. I'm just going to talk a little bit about how the data can also be geospatial and what kind of benefits that can provide.
Yeah, thanks, Stephen. Here we have a georeference 3D map. This was created using LiDAR mounted on a vehicle. It's a different kind of system than the ones installed on the bridge and here on the junction. But what I would like to point out here is that this data is georeferenced, so it has a location on the real world, and the accuracy of this location of these points is such that you can actually tell if, for example, a bicycle is on the road or on the pavement, for example. So that level of accuracy is something we can achieve, or even if a person walking on the pavement is in the middle of the pavement or one side of the pavement. So this is just an example of the type of accuracy that we can get, there are several applications for this, obviously.
And I just want to touch on, we've spoken about lots of potential data analysis and application development that we do on behalf of organisations, but we understand that a lot of organisations have capabilities in-house or might already be providing a service where they see that this sort of level of detail might complement their offering. So this is an example of one of our integrators with their digital twin engine, where we just feed our data through an API into their system. So that could be fed into your existing ArcGIS system, say, or your own digital twin system. So we are open to collaboration with lots of different organisations and working with local authorities if you've got your own GIS system or analysis capability in-house. We understand this technology is obviously compelling for ITS and smart cities, but we understand it can be applicable across a wide range of industries and applications. So if you feel that this is some crossover with yourself, please reach out at inquiries@digiflec.com, or put some questions in the chat and we can answer them now if you want. Thank you very much, and back to you, Maddie.
Thanks, Steve. That looks amazing. I must say, I'm quite impressed. And we do actually have some questions from our audience today, and also please, by all means, put in any questions. If we don't answer it fully, we'll get in touch with you after this webinar. But the first question is of, and I hope I pronounced that, Baljeet Bamra, and he's asking, if this has been used for pedestrian security, and I think that's maybe one for Steve to answer.
Yes, the LiDAR sensors have a lot of benefits in the security application, mainly because it's working in a 2D plane and getting accurate dimensional information. So you'll see in security applications, you'll get a lot of false alarms with camera, like an animal runs past or a bag's floating in the air past the screen, because it really doesn't have that accurate 3D dimensional information about the object. So LiDAR systems are actually very good for security applications, and they are being used across the globe right now, and typically for critical national infrastructure or high net worth individual security systems. But yeah, they have a lot of benefits when they're being used in that sort of application.
Then he also wondered if then, I think you touched on this in your presentation, can it be used to change the traffic flow, routing, and lights, and so on? I think you've already answered that, haven't you?
Yes. So the system can provide the information to aid traffic logic control system. It's not something that we've done, but we know that it's something that has been done across the world, and we'd be very happy to speak to organisations that are responsible for the logic system to understand how the system could possibly integrate and maybe do some trials in that area.
Brilliant, thank you. And I think we have one for Dundee City Council, maybe with Doug. Could the technology and data that is pulled out help with future-proofing the bridge, as it is a vital link between Fife and Dundee? What's your take on that?
I think Alan's probably better placed to comment on the
Or
bridge
Alan,
piece, but I
yes,
think
yeah.
no, I was going to say, but I think the data piece is, that's a key one. I think there's a broader bit there in terms of smart cities, just in terms of, I think, as we kind of have lots of demands as a council in terms of what we need to deliver, things like our city centre strategy is looking to double the population in the city centre in relatively shortish period of time. We're gonna need to utilise as much data as possible to kind of help drive that decision making. And I think that is going to be a key piece, is the data we can collect from not just this system, but systems like this, and making sure we can kind of generate good quality intelligence of that, not just for the bridge, but for our city centre as a whole. That's going to be a vital piece of the puzzle in terms of making sure we're designing. So, for example, we're if we're looking to move away from car-centric design in the city centre, making sure we understand the traffic flows, where people go, where cyclists go, and that allows us to design things a bit better. Yeah.
And Alan,
I don't know if Alan's got
obviously,
anything.
the bridge like no other.
No,
How do you see that?
I would agree. I would agree with Doug, Maddie. And I mentioned it in my chat. Information is critical. If you don't have the information, you can't do any planning. Obviously, understanding the number and volume of weight of vehicles using the bridge allows us to plan for asset management, to make sure that we're targeting maintenance appropriately, and allow us to work out where funds should be directed perhaps more accurately. But I do understand it would be important to Dundee City Council as well, the amount of traffic that we're delivering into the city every morning. It'll give us more of an indication of, is the traffic coming in peak flow times in the morning? Is it commuters? We think it is commuters on the Tay Road Bridge. The majority of people going in the morning, and then they come out again at night. It would allow interaction with other what would the word be using? Your active travel requirements. If you're trying to encourage people to get out of the car, take public transport, it would give you an indication of how well your strategies are working on that front. So it would give you that backup understanding of options you're trying to change the dynamic of people's driving behaviours, push them more into getting the bus, push them more into walking and cycling. Then getting that data will really understand whether initiatives are working or not.
Interesting.
Hope that's
And
okay.
Doug, just a quick question: does Dundee have an active travel strategy and policy?
We do. I mean, I'm probably not best placed to comment on that, I should say, but certainly we have quite big ambitions around, looking at the city centre and how can we design it better from an active travel perspective. You do get a fair number of people walking and cycling in Dundee, but I think it's probably safe to say, like most cities in Britain, our kind of city centres maybe not quite as well designed as it could be to facilitate that. So yeah, we certainly do. Yeah.
One then for probably Andre, maybe Stephen. A quite technical question. It's George Brown of KL Systems, and he's curious, like, what kind of spacing do you need to be effective on a motorway?
Okay, I could take that one.
Or Steve, yeah.
Yeah, so on the motorways, the highway applications, we use that directional long-range sensor. So currently the sensor we use for highways has a 500-meter range. When we're tracking dark objects, when we've spoken about that reflectivity point, so when we're tracking, we probably track about 250 meters against dark objects. So with the current sensor we have, you'd want to have them spaced 500 meters apart, so they're covering 250 meters to and from. There's new sensors being developed and coming out, which are going to have a 1 kilometer range. So again, once they come out, we can assess their performance in that application. But for right now, I would say you want to have them spaced 500 meters apart, looking towards each other.
Thank you. And George, if you have any follow-up questions on that, please feel free to put them in Q&A. We have an anonymous user, and this is always maybe a tricky question to answer because the answer is always it depends. But he wants to know, what is the ballpark cost of a sensor and what level or complexity of processing is needed to use the data effectively?
Yeah, so yeah, you're right, Mary, and I'm sorry, anonymous user, but it's a really difficult question to answer because there's such a wide range of sensors that could be used, and depending on the number of sensors in the area of the world that you monitor would then determine what sort of processing power would be required. I think which might be good is reaching out to maybe talk about a specific application you have in mind, and then we can maybe assist with some ballpark figures for that application in that monitored area.
Thank you, Steve. Question by Janice. She can see the application across many industries, and she's wondering, how can we raise awareness across these sectors, across these industries, because at the same time it adds to the agenda of building the digital economy and building community wealth and equipping generations with digital skills. So how can we raise awareness? And I'm not sure who's best placed to answer this, but maybe Steve, do you want to have a go?
Yeah, sure. Yeah, I mean, I think definitely everything's moving to this sort of angle, like digital, and I think working with from way down into schools to colleges to universities to highlight this sort of technology and the skills that are required to take this to like full end-to-end solutions is definitely, we need to kind of engage people at a young age. This is definitely where things are going. Obviously, everything's moving digital. So yeah, I think there's definitely work to be done. And I think through our engagement with local authorities and things like the tech scaler communities, it was unfortunate what happened to Code Clan, but I think more sorts of services such as that can go a long way in Scotland to help in growing that digital capability, because there is, especially around the technology we have, 3D LiDAR sensors, there is a lack of experience in Scotland. We are typically having to go down to the main areas where the automotive industry is to try and encourage people to come and help us from there. But yeah, I think if we can start to work with these sort of organisations like tech scalers and local colleges, I think that's definitely a place we should be starting.
Yeah, and I think, Steve, just from a personal perspective, maybe I think the people that are on this call today, we very much welcome you to champion some of this technology and to network with us, as you will have the right contacts in your network within your local authorities and within the organizations you work with. And I think from you know, as a tech company ourselves and being quite young and innovative, we are definitely there to support initiatives such as these. So we're always happy to communicate. A question from Emine Agun. He's joining from Edinburgh Napier University, and he is curious about the policy implications of the data collected. How do you think they would inform transportation, making transportation more sustainable in Dundee? And would you consider make the data open, partially or completely open? And I think, Doug, you might not be best placed, but you do work for the council, so I'm gonna have to go back to you.
Yeah, absolutely. So yeah, I think certainly on the first, you know, on the first point there, you know, that's certainly something I think we can look at. You know, we'll obviously be producing data out of this project, but you know, is there anything, you know, what are the other kind of potential uses of this? I suppose on point two, you know, we as a council do technically have an open data policy. You know, we have looked at publishing our analytics data from our CCTV camera, which is a different setup, obviously, but that's certainly something we've looked at. So yeah, I think if we were producing this on a regular basis, I think that it would be a prime candidate for publication as open data.
And I'd like to also add that we are totally open to collaborating with academic institutions, people that are researching in this sort of area, to work with us. You know, we have a lot of data. We're really open to sharing that data with academic institutions and identifying potential people that could help our organisation too, you know, once they finish their qualification. So please reach out, and we'd be happy to kind of have conversations with you about that.
Thank you both. Thank you.
A question from Lynn Short. The 5G area has a number of events, and often the traffic is forbidden when these events are on to support pedestrian safety. Can this system allow coexistence if there's more real-life information? So, Lynn, do correct me if I'm wrong, but are you asking, does this system work alongside other systems like potentially CCTV? Thinking, we'll just go with that. So does this system work alongside other systems, Steve?
Yeah, I mean, as I spoke about at the very end in terms of making the data available through APIs. So if there was somebody that was managing the security around an event and our system was in place around that area, then potentially they could integrate the data from our system with other data sources to complement each other.
Brilliant. And Lynn, if that didn't answer your question, please feel free to put a little message in the chat. Question from James Thompson is, what consideration has been looked at for both road and rail 5G corridor operation for connectivity and efficiency of infrastructure development? And maybe this is a good one for Jack. Would you be comfortable with that?
I can tackle that. I mean, it's a simple answer, really. The consideration for public broadcasting of 5G in those areas is really up for discussion with the major network operators. They are guided by the UK wireless strategy, which published last year, but there is no onus on them improving or creating a specific coverage network across those areas. That being said, in the private space of those who are actually operating and managing these infrastructure, which is the likes of ScotRail and companies like Bear, they are looking at private network capability. They are looking at Open RAN. Open RAN is a buzzword you'll hear a lot around providing infrastructure that MNOs can use. And this is something that is it's in its early stages of development, but rail operators are looking at how they can provide infrastructure on our trains, and equally the people who run our highways, for example, they are looking at how they will implement a private network that can manage infrastructure mainly, but it will have capability in the future to be opened up for MNO usage. But there needs to be some buy-in from major network operators for that to be utilised.
And Jack, on the back of that, a quick question from Tommy Evans. He's wondering who provides the 5G network in this project?
Okay, so it's a Nokia NDAC solution for the private network solution here. That's a Nokia NDAC standalone N77 network that is partially owned by DCC. There's some funding from the Scotland 5G Centre for an element in the cyber quarter, and Abertay University as well, who manage the security and backhaul as well as their own infrastructure in their building. That is supported by one of our network partners, a supplier called AWTG currently, and the public broadcast, which is the single LiDAR sensors connected to, and that is on the E network, Steve, I believe. It's not shaking his head, so I think it's the E network.
Yeah, EE. Yeah, sorry. Yeah.
I had a 30% chance of being right there, so there you go.
Thank you, Jack. And I think we'll squeeze one final question in before the webinar is finished. And it's another question from Baljit Bamra. And he asks, you may not be able to answer this, but what sort of data volume is typically transmitted in the setup you have now? And I think that's one for Andre and Steve.
Yeah, I think, Andre, can you answer the bridge one and
Yes.
I'll answer the city one?
Yeah, I know the bridge without any optimization, we're transmitting roughly between 300 and 400 megabytes per day. So that's without any optimization, so it can be reduced. Obviously. That's it.
Yeah. So the city deployment where we are transmitting purely over the 5G network with the edge compute remote, that's each sensor is transmitting 30 to 40 megabits per second with the raw data. So on the bridge system with the public 5G network, we do some edge computing there, which reduces that data volume. But when it's a direct transmission, depending on the sensor, but the sensors we use in the city are between 30 to 40 megabits per second, but depending on the sensor, that can range all the way up to 80 megabits per second.
Just to cover a little point on that, Stephen, there's another element in relation to latency there that's really important. So the data rate's great, but if you're going to do anything live, you need to be getting that in real time. So sub 50 milliseconds is ideal for that safety element.
Definitely.
Great addition. Thanks, Jack. Right, so this concludes the webinar today. So what happens next is I will send an email to everyone who's joined us today with the recording of the webinar and also some more links or details about this project and future project, or an invitation to discuss future project with us. As Digiflec is very keen, and I know Tay5G and Dundee City Council are very keen to explore new use cases, to go to new areas, and to keep developing this technology to contribute to safer and more efficient roads and other structures. So thank you very much to our panelists today, and thank you everyone for joining today.
Thank you, everybody. Bye-bye.
Thank you. See you later.
Thanks, everyone.